In the today's class, I am going to explain what are the different formulas are required to solve the problems related to metal cutting process. The main aim of this session is to familiarize different formulas used in metal cutting and instructional objectives. So in this session we designed to understand how to determine the cutting forces, to familiarize the participants with various mathematical equations used to calculate cutting forces, frictional forces, all related metal cutting formulas are familiar the students, and after completion of this session students are able to understand the mathematical formulas used in metal cutting and identify different parameters involved to determine various components in metal cutting. Now let us see that what are the different formulas are using. So the cutting speed is denoted the letter V. V is equal to pi into D into N. Whereas V is the cutting speed in terms of meters per minute or feet per minute. D is the diameter of the cutting tool. The units are mm or inches. N is the rotational speed of the cutting tool. The revolutions per minute and units. The units are very important because finally the cutting speed units are the meters per minute. Accordingly, the substitution data also you can use all the similar data units. Now the second formula, spindle speed N. N you can determine V into 1000 divided by pi into D. What is the N? N is the rotational speed of the cutting tool, that is the revolutions per minute. V is the cutting speed, that meters per minute or feet per minute. And D is the diameter of the cutting tool, that is the mm or inches. Third formula, feed rate. F is equal to N into Z, where F is the feed rate. What are the units of feed rate? Mm for revolution or inches for revolution. N is the rotational speed of the cutting tool, the revolutions per minute. Z is the number of cutting edges on the tool, usually 1 or 2 cutting edges. So the metal removal rate, MRR, is the metal removal rate that you can find out F into L, where MRR is the metal removal rate. The units are mm cube per minute or inches cube per minute. F is the feed rate, that is mm for revolution or inches per revolution, and L is the length of the cut, that is in terms of mm or inches. Next, fifth one is machining time. You can determine the machining time, that is L by F. T is the machining time in minutes. L is the length of the cut, that is in mm or inches. F is the feed rate, that is mm for revolution or inches per revolution. The sixth formula, power required. The P is equal to MRR into Kc into alpha plus Kt into Y divided by 1000. Where P is the power required in kilowatts or horsepower and MRR is the material removal rate, that is mm cube per minute or inches cube per minute, and Kc is the specific cutting force, that is in terms of Newton per mm square or PSI. Alpha is the shear angle in terms of degrees, and Kt is the tangential cutting force, that is the Newton per mm square or PSI, and gamma is the rake angle in terms of degrees. 7. Power consumed at the cutting tool, PC, that is Fc into Vc. What PC is the power consumed in watts, and Fc is the cutting force in newtons, and Vc is the velocity of the chip in meters per second. Work done in shear. The work done is the cutting force into the length of the shear, Fc into L, where Ws is the work done in shear, that units are joules or Newton meter. Fc is the cutting force in newtons, and L is the length of the shear zone in Newton. Length is in meters. Next, the torque developed on the workpiece. How much torque you are applying, that is obtained, T is equal to P into 60 divided by 2 pi N. What is the T? Torque developed on the workpiece. Units are Newton meter or lb feet, and P is the power required in terms of kilowatts or horsepower. N is the rotation speed of the workpiece, that is revolutions per minute. Next, 10th is the shear angle alpha, that is equal to arc tan of beta by cos psi. What is the alpha? Alpha is the shear angle in degrees, beta is the back rake angle in degrees, and psi is the friction angle in degrees. Once if you know the three angles, you can find out the shear angle alpha. Shear strain. The shear strain is tan alpha by 1 minus sin alpha, where gamma is the shear strain and alpha is the shear angle or degrees. 12th, coefficient of friction. Mu is equal to tan pi, where mu is the coefficient of friction and pi is the friction angle. 13th, cutting force. Cutting force is obtained Kc into MRR. Fc is the cutting force in newtons or LBF, and Kc is the specific cutting force, that is Newton per mm square or PSI, and MRR is the material removal rate, that is mm cube per minute or inch cube per minute. 14th, thrust force. Ft is equal to Fc into tan alpha, where Ft is the thrust force N or LBF, Fc is the cutting force N or LBF, alpha is the shear angle in degrees. 15th, radial force. Fr is equal to Ft into tan pi, where Fr is the radial force, that is in newtons or LBF, Ft is the thrust force, the newtons or LBF, and pi is the friction angle in terms of degrees. 16th, resultant force in orthogonal cutting, that R is equal to square root of Fc square plus Ft square. And resultant force in oblique cutting, R is equal to square root of Fc square plus Ft square plus Fr square. The three component of forces are acting in oblique cutting. So the 18, chip thickness ratio, that is the T naught by T, where R is the chip thickness ratio, units are nil, and T naught is indicates the uncut chip thickness in terms of mm or inches, and T is the chip thickness after cutting in terms of mm or inches. 13th, length of chip removed. L is equal to F into L, where L is the length of the chip removed in mm or inches, and F is the feed rate mm for revolution or inches for revolution, and L is the length of the cut, that is in mm or inches. 20. Cutting ratio. The CR is equal to L by D, where L is the length of the chip removed, that in terms of mm or inches, and D is the depth of cut in terms of mm or inches. 21. Compression force. Fc is equal to T into W into D, and T is the chip thickness after cutting in terms of mm or inches, W is the chip width in mm or inches, D is the depth of cut in mm or inches. So 22. Velocity of the chip along the tool face, that is obtained pi dn by 1000, where Vc is the velocity of chip in meters per second, and D is the diameter of the cutter in mm, and is the spindle speed in RPM. So normal pressure on the chip, that is obtained by Fc by A, where P is the normal pressure in pascals or Newton per meter square, Fc is the cutting force in newtons, and A is the area of the shear zone in terms of meter square. And feed force, that is Fc into cos alpha, Ff is the feed force in terms of newtons, Fc is the cutting force in newtons, and alpha is the angle between the cutting force and the feed direction in radians.